Pretty simple day today. All of these things right here are like pretty much equivalent verbiage that we use in algebra class. So if you've got some polynomial like f of x, like you could say that if you had something like this, sometimes you see this c value like x minus c, you know, if f of x equals a 0 or whatever, c is a 0 of the polynomial, c is a root, you know, those words are interchangeable. It's like find me a 0, find me a root, and it's like they mean the same thing. Like a 0 is where it crosses the x-axis at, root's where it crosses the x-axis at. But then when you go backwards, like let's say that 2, let's say you had a graph right here. Color. Can you tell me what kind of degree this puppy has right here, even or odd? That's got an odd degree. And let's say that there was a 0 at 1. Is that cool with you? Right there, there's a 0 at 1. Well, that means that x minus 1 is a factor of that. You know, this is really the equation f of x equals x minus 1 cubed is what that really is right there. That's the old parent function of the cubic, and didn't it slide 1 unit right? Correct? That's what this means. It slid 1 unit right. It's the old opposite of what you think. When we did the purple note card kind of stuff, you know, the old graph translation theorem, stuff like that. Well, 1's a root, but isn't x minus 1 in quantity a factor of that? So, and then if c is real, then c comma 0 is an intercept, so this is the point 1, 0. Interesting. If c is real. Today, what we're going to do is find all the roots of a polynomial. All the roots. There are real roots, and there are also imaginary roots. So the big question, what? Why would there be imaginary roots? Like, what's that even all about? If you're interested in engineering, and especially electrical engineering, like to be some sort of really fancy schmancy electrical engineer, you will use imaginary numbers all the time. What for? I don't really know. I'm not an electrical engineer, you know what I mean? But trust me, that's where it came from, kind of ideas. Like, we need to know something about these numbers right here to help us do these particular problems. So those are really where a big chunk of imaginary numbers came from, is in electrical engineering and stuff like that. So whatever, fundamental theorem of algebra says this: every polynomial equation with a degree greater than 0 has at least one root in the set of complex numbers. So if you got a first degree, second degree, third degree, or even further, it's going to cross the x-axis in the complex numbers. Meaning, you know, you could have something like this. Doesn't that have a second degree polynomial right there? That's a quadratic. And it doesn't even cross the x-axis at all. That means that there's some imaginary roots to it. So there are either real or imaginary, and you put them together and you get the complex numbers. Remember, complex was a plus bi, to where this is a real part and this is an imaginary part, and if you add a real and an imaginary number together, you get a complex number. Sounds complicated. It's really not. Once we see the problems that we're going on today, it'll be like, oh, that's all right, you know. So if you got some sort of polynomial, p of x equals 0 with degree n, it's got exactly n roots. Moral of that story: whatever the degree is, that's how many roots it has. If it's third degree, it will have 3 roots. It might be that they're not all real. Some of them will be imaginary, but a third degree will have 3 roots. A fourth degree will have 4 roots. How much will a fifth degree polynomial have? 5 roots. Just that simple. Whatever degree it is, that's how many roots it has. Some are real, some are imaginary, whatever. Okay? So that's what's rolling on there. And then here's something I'd like you to jot down right here. It says the complex conjugate theorem. This is what it really says in math language. Here's what it says in English. If you get an imaginary root, its conjugate is also a root. I'll say that again. If you get an imaginary root, its conjugate is also a root. So for an example, let's say we did our algebra today and we got the root of something to be 2i. The conjugate of that is negative 2i. You know, because it's really, if you think of it as a complex number, this is really what 2i is as a complex. 0 plus 2i, wouldn't the conjugate be the exact same thing but switch the sign, 0 minus 2i? So if you get an imaginary root of like 2i, you automatically know that negative 2i is also going to be a root. Same thing with an irrational root. If you get an irrational root, its conjugate will also be a root. If you get an irrational root, its conjugate will be a root. it always gets confusing, the I words, imaginary, irrational. What's an irrational number? Give me like an example of an irrational number. Square root of 3, right? It's some sort of root, like a square root or even a cube root or something like that, to where it's not a perfect square or it's not a perfect cube. So if you got the square root of 3 for an answer, what's the conjugate of the square root of 3? If 2i was a root, its conjugate was negative 2i. What's the conjugate of square root of 3? Negative square root of 3. So this will come in handy later. I know it's a lot of information at first. Here's what we're really going to do today. So let me get my calculator open here for a second. Finding exact zeros of a polynomial. Same thing as exact roots. You know, words are interchangeable. There's a systematic way to find the exact zeros of a polynomial. What you did just on the homework quiz and on the homework last time is sometimes they came out nice, sometimes they came out decimally, correct? You rounded those decimally ones off. We're going to find exact ones today. Like, where were they exactly? So here's the first thing that we do. They give us a polynomial. It needs to be set equal to 0 first, right? So that's what has to happen. Then using the degree of the polynomial, determine the number of zeros it will have. Here's our polynomial equal to 0, yes or nay. What's the degree? 3. That means it's going to have how many roots? 3. So right here where it says zeros, blank, blank, blank. We're going to fill in those blanks. We're going to find those 3. I want to put those blanks so I know how many zeros I'm supposed to go and find. Sound cool? The way we're going to do it is first we're going to graph that thing on our calculator. Pa-pa. So that's x cubed plus a 4x squared plus a x minus 6. Got it typed in correct. Let's just zoom 6 in and see what happens. It's a third degree. There's supposed to be 3 zeros. The question is, how many do you see? There are 3. That means that all of them are real, right? We can see all 3 of them. If you didn't see 3 of them, right, then that meant there'd be some imaginary roots also. But I can tell you already, because this is third degree, it's going to have at maximum 3 zeros, and there they all are. I'm pretty zoomed out. I don't like it. I like the 5s all around instead of the 10s all around, so let's change that and see if we can see things a little bit better. I like 5s all around. The easier it is to see where those things cross the x-axis, the better we can do some guessing. I'm looking for those 3 roots, and I want to use that cool trick of guess and check. Here's a root right here. Take a wild guess where you feel that that root would be at. Negative 3? Well, that's a guess. I agree with your guess. Let's check it. How do you do that? Trace negative 3. Did that turn out to be a root? So it goes into blank. There's one of our roots right there. That's all we're asking. Where's our zeros? Where's our roots? One of them was at negative 3. Cool. Next one. Would you take a wild guess of where that puppy's at? Negative 2. Sounds good to me. Double check. Oh, yeah. That turned out to be a 0. And one more. Trace 1. That worked also. How awesome. Done. They wanted to know where were all the zeros. It was third degree. There's supposed to be 3 of them. And in this particular one, didn't they all come out beautifully integers? Sound cool? Let's go to the next problem. Is that polynomial equal to 0? Yes or no? Is he equal to 0 already? What degree is he? So how many zeros will he have? Put 3 blanks. 1, 2, 3. Let's type it in and find them. Clear. X to the third minus 5x squared plus 5x plus 3. Double check that you got her punched in right. Awesome. I'm just going to hit graph because I got 5s all around. There's supposed to be 3 zeros. How many do you see? 3. That means they're all real numbers. Okay? They're all real numbers. None of them are imaginary. Ooh, this one doesn't look so nice. I don't even know about that one. I don't know if that looks that nice either. Do any of them look nice? Not at integers. You with me on that? Not at integers. Well, I don't know. Maybe this one's nice. This one is the closest to an integer. Would you agree with that? What do you want to try? Trace what? Ooh, was it 1? Yeah, my eyes fooled me, so I know that 3 is a 0. Cool. The other ones, they could still be rational. Like, like 1/2. Isn't 1/2 a rational number? We want to see if these are rational or not, so let's do the old intersection trick. Let's figure out where this puppy's at. So when you have your y equals, remember you got your polynomial up top, and you got y equals 0 for your second one. Let's second calculate a 0. And then I didn't want to do that. Second calculate intersection, my bad. Then I want to do first curve, second curve, and I'm going to guess. I got to move my cursor basically right by it. Is everyone cool with what I'm doing so far? Hit enter. Here's the thing. Did that come out to be rational, which is either a clean decimal, like 2.5, or a repeating decimal, or anything like that? Is that rational? That's an irrational answer. Is that all right with you? Now look at what you wrote in that box up there at the top. If there's one irrational answer, you automatically know that its conjugate is going to be an irrational answer also. So this guy over here, I don't even need to check him. Since this is irrational, this guy has to be irrational also. Is that with you? They come in pairs. Sound cool? They come in pairs. So how do we find this guy? I don't know what that is. We do a little thing called synthetic division. So how do we solve this? We use synthetic division. Now, back when you did a polynomial division problem, like if you took this puppy and say you wanted to divide it by x minus 3, you see how this was a factor of it, and you divided by the real 0 of it. What did you synthetically divide by if this said x minus 3? You divided by what? 3, because 3 is the root of that problem, right? 3 is a 0. Here's the thing. When we do our synthetic division now, tell me about this number 3. Isn't that a 0 right away? That means that's the number we synthetically divide by. We do not change its sign. We only do that if they say, please divide by some sort of polynomial like this. It's like, oh, that's a factor. I need to divide by the 0. You always divide by what makes it a 0, and 3 would make this a 0. 3 makes this thing a 0. That's what 0 means. 3 is a 0, so let's do synthetic division. We'll do our 3, and then we just take this puppy, and we put them in there without the equation part. All the coefficients, and if there needs to be a placeholder, we'll put our placeholder. I don't need the plus, sorry. Now slow down, don't get ahead of me. I want to explain some stuff. Isn't this a third degree guy? So that means there has to be 4 dudes in my synthetic division thing. Here's what has to happen. Our remainder has to come out to be 0. Because isn't that a 0 in the first place? That means that when you divide this polynomial by x minus 3 is what we're really dividing by, it goes in there evenly, right? It's supposed to go in there evenly because 3 is a 0 to this thing. So moral of my story is, when you're doing all this stuff, your remainder has to come out to be 0. If you don't get 0 for a remainder, you made a mistake. Okay? So let's synthetically divide. Tell me that step again. What happens here? First guy comes down, and then you put a 1 there. Multiply. That gets to be a 3. That's a -2 when you add them up. Multiply again. You get a -6. Add them up. You get a -1. And now I know for sure that everything is all good in the neighborhood, because what was my remainder? 0. Now, why did we synthetically divide? Here's why. Because what degree was this thing right here? What degree was this thing right here? Third. Do you know how to solve a cubic? Do you know how to solve a cubic equation at all, like to solve or anything like that? You don't. When we synthetically divided it, though, isn't this x squared, this is x to the first, and this is our constant term right now? We know that this right here, let's write it as x squared minus 2x minus 1. That's a quadratic, correct? Can you solve a quadratic equation? Do you know how to do it? Yes. We want to know when this thing equals 0, so you will take this quadratic and set it equal to 0, and let's solve it. And I can tell you already that factoring is going to be a waste of your time. If you go to what the instructions say use synthetic division to knock it down to a quadratic. That's what it really says. Then it says use the quadratic formula. or some other method? Let me tell you why you know it's not going to be factorable, because tell me about this root. Is it rational or irrational? It's irrational. If it was rational, you could factor this. This can't factor right here because you get an irrational. It crosses the x-axis at like a square root of 5 or a square root of 3 or some sort of irrational number. So your two options, since it's not factorable, is to do the quadratic formula or complete the square. And I think that complete the square is the easiest way, because what's the a value of this quadratic? A value is 1. What's the b value? Even. So let's set this thing up to complete the square. I know it's been a while. Here's how we do it. That's where we set it up with blanks. So x squared minus 2x plus blank equals 1 plus blank. You have to add that guy over, right? We got to set this equal to 0. Excuse me, set it up with blanks, and all the constants go to the right side. How do you fill in the blank? How do you do that again? Half the b value, which is -1, and do what to it? Square it. 1 goes in each blank. And they're both the same blank. It's a plus blank and a plus blank because they're on different sides of the equal signs. You do the plus blank and the minus blank when on the same side or on different sides, so it's the same thing. Cool? The reason why we did that is because this is a perfect square trinomial. It factors into x minus 1 quantity squared. Where did that minus 1 come from again? It's half the b value. And that will equal how much over here? 2. Sweet? This better not be a perfect square because it's not supposed to be factorable. Now, how do you get rid of the square? You square root both sides, correct? So, what's the square root of x minus 1 quantity squared? X minus 1. And what's the square root of 2? Plus or minus the square root of 2. Do you see how we get that irrational answer right there? Solve for x. What does x equal? What do we need to do to solve for x? Add 1. Just put this. X equals 1 plus or minus the square root of 2. How many answers are there, Billy? How many answers are right there? 2. And they are conjugate pairs of each other. Let me get back to my little blank right here. One of them was 1 plus the square root of 2. And what's the other one? 1 minus the square root of 2. Do you see how those are conjugates of each other? You got like 1 plus the square root of 2 and 1 minus the square root of 2. Woo! There's all of our zeros. Let's try it again. Yes. What's first step? Get it equal to 0. Right? Get it equal to 0. So that'd be x cubed minus 6x squared plus 13x minus 10 equals 0. This is a cubic. How many zeros will it have? 3. 3 blanks. Meow, meow, meow. Punch them in. X to the third minus 6x squared plus 13x minus 10. See what it looks like on that 5s all around. Supposed to be 3 zeros. Right? Supposed to be 3 zeros. How many do you see? 1. Smells like the other 2 are imaginary. But we don't know that for sure. There could be multiplicity at this also. We find out by doing synthetic division. Is how we find out. First, can you find any 0? You've got to be able to find at least 1 0 before you can do the synthetic division. Where do you feel that that one's at? 2. Let's double check. Trace 2. And it is a 0. So that goes into blank. Cool? That means we synthetically divide by the 0. Should we synthetically divide by 2 or by -2? What should we synthetically divide by? 2. Make sure you get all the right spots in there if you need any placeholders or not. Once you do your synthetic division, what should your remainder come out to be, since we know that 2 is actually a 0 to this thing? The remainder should be 0. So that's how you know if you did the synthetic division right. Boom. Yes, no, maybe on synthetic division. What do we use this for? Here's our quadratic that we now have. We've got x squared minus 4x plus 5. That's what that really means. Okay? I want to take a pause for a second. I want to tell you something. This is a root, correct? That means that x minus 2 is a factor, and when you factor out an x minus 2, you'd get this. If you expanded this out, you would get this back for your polynomial. We just factored out x minus 2 because we already knew that 2 was the root, so its factor is x minus 2. If that makes any sense to you. If you took this times this, which is what we got right here, you would get that. Sound okay? So we are now trying to solve to figure out when this is 0. Is it factorable? I can tell you, no way, Jose, because they're not even shown up there. So let's set him equal to 0 and solve. You could choose quadratic formula, which you're welcome to do. I could care less how you do it. Or you could choose complete the square. But I think when A is 1 and B is even, that completing the square is faster. Should we complete the square? What do you think? I like it. So let's do it. I would do that over here, just for fun. X squared minus 4x plus blank equals negative 5 plus blank. Y'all down with that? What goes into blank? 4 goes into blank. Half the b value squared. 4 and 4. Sound good with that? And then this factors right here, because it's a perfect square trinomial, what does he factor to? X minus 2, quantity squared. And what do you get over here? Negative 1. Boom! Doesn't that mean to you that we're going to get imaginary answers? Because we have to square root it. So the square root of this is x minus 2. The square root of negative 1 plus or minus, what's the square root of negative 1? Square root of negative 1 equals, if you think of it like that, square root of negative 1, that's the definition of what number? I. Square root of negative 1 is I. Square root of negative 1 is I. Since we got two answers, there's plus or minus I. To get x all by itself, what does x equal then? What do you got to do? 2 plus or minus I. Cool? Here's your two answers. One of them is 2 plus I. The other one is what? Tell me about those two numbers. They are what? Conjugates of each other. Cool? There are 3 zeros. What are the imaginary answers used for? Become an electrical engineer and find out. This is what I'll really tell you. Okay? Next. Set them up for me. How is he equal to 0? Yay or nay? Yep. How many blanks would you put? 4 blanks. Fourth degree, 4 blanks. Let's see what we got. X to the 4th minus 21x squared plus 80, right? And I'm still, my window is 5s all around. I'll just hit graph, see if it looks good or not. Maybe I got to change my window, but make sure we're typed in right. How many zeros maximum would you see? 4. Do I see them all? Yeah. So let's see if any of them come out real nice. What do you think about that one? Negative 4. So trace negative 4. Come out nice? Good. Don't stop there. If there's any other ones that we could find, that'd be good. What do you think about right here? Trace 4. Double check him. Don't assume. The real ones don't come out in conjugate pairs. Okay? The real ones don't. Sometimes they do, sometimes they don't. But 4 was a 0. Awesome. This one, can you tell it's not an integer? Because it's not on one of those nice, neat tick marks. It doesn't mean it's not rational, though. So check him, right? Second, calculate. Boom, boom. You don't have to check them both. Where did I go? Second, calculate, 5. First curve, second curve. Just check whichever one of those is closest to you. Ah, you dirty dog. Did this guy turn out to be rational or irrational? Remember, rational numbers are an ending decimal or a repeating decimal, like 2.3333333. Is that rational or irrational? That's irrational. So that means you automatically know this other guy's irrational also. So here's what we got to do. We got to do a synthetic division. By which one? It doesn't matter which one. You got to synthetically divide by one of these. Let's just work from left to right. Let's synthetically divide by -4. Cool? Slow down. Let's do this together. Placeholders, you got to have them. 1 cubed squared first power constant. Slow down. I want to talk you through this. Let's realize what's going to happen. Did you have the right coefficients in your synthetic division thing? This is a 4th degree. We're going to divide it by a 1st degree. What will it turn it into? 3rd degree, right? It's going to turn it into a 3rd degree polynomial. So let's do that. Let's do our synthetic division. And once we do that, it'll knock it down to a cubic. It's 4th power. We're going to synthetically divide. It'll knock it down 1 degree. What should our remainder turn out to be? It's got to turn out to be 0. Let's see. -4, that'd be +16, if I can erase things correctly. +16, right? Then you get -5, right? -20, +20, -80, 0. Didn't that work? Right? Here's the problem, though. This is x cubed minus 4x squared minus 5x plus 20. That's a cubic. Do you know how to solve a cubic? I don't know how to solve a cubic either, right? So what we do is we have to synthetically divide again. Didn't we already use -4, though? What will we synthetically divide by again? +4. So just keep on doing this. You don't have to rewrite anything. Just put yourself in another box. Put yourself 4 right. Because you're going to need all the coefficients. Those are all the coefficients, right? You just keep on moving down. Is everyone good with that? Then synthetically divide. We keep on synthetically dividing until we get a quadratic. You better get 0 again for a remainder. Right? Every time we do this, we're dividing by a 0. You get a remainder of 0 when you do that. Now, is that a quadratic? Because there's 3 guys. It's x squared minus 5 is what that really turns into. Cool? X squared minus 5. What do we want to know about x squared minus 5? We want to know when it is equal to 0. We want to know where that 0 is. Rock and roll. You could complete the square. You could do the quadratic formula. Or you could realize that it's only x squared and no x to the first in this thing. Couldn't we just square root the dang thing? Like get x squared all by itself on one side of the equal sign? So what would you do when you get x squared all by itself on one side? X squared equals how much? 5. That makes sense? Just add 5 to both sides. Now, what does x equal? Plus or minus the square root of 5. That's an irrational answer, correct? And one of them was square root of 5. The other one was negative square root of 5. Those are conjugate pairs also. Nice. Next one's all you, baby. You and pal, get the next one done. Make sure it's equal to 0 first. Set it up with blanks. Graph it. Let's find all the zeros that we got. Give the whole thing a shot. Meet me back here when you're done. Punch it in. Should be 3 zeros. Find there's a nice one at 3. Synthetically divide by 3. Your quadratic is x squared minus 2x plus 5. And then we want to know when it's equal to 0. Cool? You could use quadratic formula. You can complete the square. What do you want to do? I would complete the square also if a is 1 and b is even. If that's not the case, if a is not 1 and b is not even, I would use the quadratic formula. Right? You know, it's up to you, whatever you want to do. But then that'd be x squared minus 2x plus blank equals negative 5 plus blank. What goes into blank? Half of this is negative 1. Put in a 1 and 1. X minus 1 quantity squared equals negative 4. That is not a perfect square. If it was positive, it would be a perfect square, but it's negative. You with me on that? So we can square root it, though, and it comes out real nice. X minus 1 equals, what's the square root of negative 4? More than 2i, plus or minus 2i. You with me? if it's a perfect square but it's negative, just square root it and put the I with it. And then x equals 1 plus or minus 2i. So back up where you had it, you do 1 plus 2i and 1 minus 2i. What are those called again? Conjugates. Next one. Oh. Is it equal to 0? Yep. How many blanks do we need? 5 blanks. Oh. If you like to synthetically divide, this is a problem for you. Clear. X to the 5th minus 81x. Yes? Graph him. 1, 2, 3 is all I saw. I don't like the way that looks. I don't know enough about it. You know, I'm going to zoom out. You know, I don't see really what's going on, so I'll just zoom 6 and see what happens. Didn't really help. Didn't really help. That means to me that maybe I'll just stop zooming out and start seeing where them zeros are at. How many zeros do you see? 3? There's supposed to be 5. Well, let's take a wild guess. Where do you feel that this one's at? So trace negative 3. Yep, that's a 0. It's hard to see, you know, but I see 3 zeros. Do you see 3 zeros? Like I said, it's hard to see because it's so straight up and down. Where's the next one that you feel at? So trace 0. Yep. And trace 3. Yep. Here's the good news. How many don't you have? 2. Because if they were imaginary, shouldn't they come in conjugate pairs? And if they were irrational, shouldn't they come in conjugate pairs? When you have a missing amount of zeros, especially in the imaginary sense, there better be 2 of them because you need a pair of them. Cool? So, time to synthetically divide. What do you want to synthetically divide by? I just work from left to right. You need a lot of placeholders, though, because how many dudes should be in this thing if it's a 5th degree? There's got to be 6 dudes in there. 4th power, 3rd power, 2nd power, 1st power, constant. All right? Just count them out. You know, here's my 5th power, 4th power, 3rd power, 2nd power, 1st power, constant. That would be negative 3. That would be 9. That would be negative 27. That would be 81, right? And then you get 0 here. But this isn't our remainder, correct? We still got to keep going. Negative 3 times 0 is 0. And then there's your remainder of 0. The problem is this is not a quadratic still. This is a 4th power guy, right? We got to keep bumping him down until he's a quadratic, so you synthetically divide again by the next 0 that you haven't used, like 0. And synthetically divide by 0 is a piece of cake. 1 comes down, right? Then 0 times 1 is 0. Negative 3 comes down. Keep on rolling. And that's why we like to put this little box here by the remainder to realize that he doesn't count anymore, right? We're done with him. You don't use him in your next synthetic division. You know what I'm saying? Like, you stop there, and you should get a remainder of 0. That's still not a quadratic. There's 4 guys in there. Quadratic has 3 guys in there. So, you got to divide by 3 again now. One comes down. That would be 3. That's a 0. That'd be 0 and 9, and that'd be 27. And I got a remainder of 0. Sweet. This is really x squared plus 9 equals 0. Correct? Subtract 9 over. Since there's only x squareds and not x to the first, you don't need to complete the square or anything like that. x squared equals negative 9, and that means you'll get imaginary answers, which is what we're looking for, and x equals what? Plus or minus 3i. So then you put them back up there in your two remaining blanks. Awesome. I will turn you loose on the next problem, and let's see if you make the same mistake I did when I did that problem. Try the next one after you've got this one done. See if you make the same mistake I do. Yes? So someone asked, does it matter what order you put these in? No, it doesn't matter. Does it matter what order you divide by over here? No, it doesn't matter, because it all has to get done, right? It all has to get done, no matter what order you do them in. Next one. Let's see if you make the same mistake that I did. 4 zeros. Here's what it looks like on a Zoom 6. I'm going to change my window to where I can see those zeros a little bit better. So like I'm going to make x go from negative 3 to positive 3 and just see what it looks like. Should see 4 zeros. 1, 2, 3, 4. Can I see them there now? Right? Maybe you don't see all 4, but it's maximum 4. And these little humps like this, they're very hard if you don't zoom in to find them all. Let's take some wild guesses. Where's some wild guesses? Negative 1, so trace negative 1. There's one of them. Right? Any other wild guesses? Trace 2. Come out nice? Okay, I'll let you finish this. Here's what's happened so far. I made the same mistake. Most people found these two roots because they're integers, right? And you could see and guess. It's like, yep, and yep. This one, you know, is not an integer, and this one, you know, is not an integer. But that's not really what we're looking for. We're looking to see if they're rational, like 1/2 or 3/4 or stuff like that. So before you go through all the synthetic division mumbo-jumbo, why don't we try to calculate this with an intersection tool? Let's second calculate intersect, and let's just see where one of those other zeros is at. I didn't move my cursor. Second intersect, first curve, second curve. Let's go over there. And, ooh, 0.25. See how that decimal came out nice and clean? I need it as a fraction, though. What's 0.25? 1/4 is a root. Find the other one. Second, calculate, intersect. Yeah. Where's the other one at? 3/4. And that means that when you did your synthetic division and you got 16x squared minus 16x plus 3 equals 0, you could have factored it. You could have multiplied those together and got 48, found two numbers that multiplied together would be 48, and add together would be negative 16, because they were rational in the first place. Moral of the story, just because they're not at nice, neat integers doesn't mean you shouldn't try to calculate with your calculator first. Excellent. All right.